Okay, so we talked about some of the different types of angles yesterday, right? So we know what same side interior angles are. So today, we're gonna talk about different theorems and postulates that go along with those angles, but under certain circumstances. So I think I mentioned it Monday. If the lines are parallel, then it makes all sorts of cool things happen, okay? So this is our transversal going through two parallel lines. So if you have a transversal cutting through two parallel lines, and one of the things that we know is that the same side interior angles are going to be supplementary. Okay, so let's see what I got here.
Wait.
So like the measure of angle 3
Yeah.
and the measure of angle 6, because they're on the same side of the transversal and they're interior, will add up to 180 degrees.
So the 180 would be counted as the transversal line?
Yeah.
Yeah.
And then these two would also be supplementary, right?
Yeah.
Because they're also same side interior. But then we can even go farther. These two are a linear pair, and so those would be supplementary. And then these two are also a linear pair, so those are also supplementary. So lots of cool supplementary things.
Mm-hmm.
So if you find out one number, you know the rest of them.
Correct.
So if the top one's
So
like
if, like,
100, Then
Yeah,
you know
so
the
like
ones
if
are
this
80.
is 100, this is 80, and if this is 80, this is 100, and if this is 100, this is 80.
This is
And then
only
you
for
can also
parallel
tell
lines?
me-
And so then you can see that these angles are congruent, and so are these. Okay, and that's another theorem, which we'll get to. Before we move on, I want you to add this, okay, to the back of the book in the special place where I told you to put all your special theorems and postulates and stuff.
the special thing.
So angle 6, so angle 6 and angle 3 are supplementary, but why? Yes. Okay, by the same side interior angles postulate. Because they're same side interior angles and they're parallel lines. Are there anything, so these two, any other angles that are supplementary to 3? 4.
Oh, yeah.
So angle 4 and angle 3. But why?
Linear pair.
Because they form a linear pair. Okay, remember, when we refer to a linear pair, we're talking about a pair of two angles. Sometimes you guys are using like weird verbiage for linear pair. Linear pair angles isn't a thing. They're angles that make a linear pair or form a linear pair. Okay, and there's no such thing as like linear pair segments. The segments are already like lines. So that doesn't make sense. So if they form a line, then they are a linear pair. So you're talking two angles at a time, no more than that, no less than that. You can't have one angle that's a linear pair. Because pair means two. So sometimes you can have like a situation like this where angles 1, 2, and 3 are supplementary, but that's not because they're a linear pair. There's 3 of them. 3 things can't be a pair. They're supplementary because this is a straight angle, and when you add them up, you get 180 degrees because this is a straight angle. Okay, so it's like the same idea, but different like verbiage. Okay, so then this says find the measure of angle 4 and the measure of angle 6. So 4 and 6 we know are supplementary. So how can we find them?
Subtract 55 from 180.
Good. So measure of angle 4 is going to be whatever 180 degrees is minus, whoops,
I'm zoned out right
55 degrees. Come back to
We'll
us.
get back in.
now. That was like really bad zoned out.
What's 50?
125. 125.
Do we agree?
Yes.
Wait, just let me measure.
I hate to distinguish.
Yeah, that's right.
This one.
What?
I got it.
Okay.
That's
And
the
then
side of
what would angle 6 be?
Angle 6 would be
125 because they are congruent.
Right. Okay, so same, we know they're supplementary. So if this is 125, okay, these are also supplementary. This is also going to be 125.
So what's that reason? Can I just say congruent?
So if you need a reason, so angle 4, this is linear pair postulate. this is same side interior angle postulate. Okay. Question? Sure? Are you with us?
Yeah.
Can I scroll?
Mhm.
Okay, find the measures of angles 2, 4, 6, and 8. Ooh. Remove my little mouse there. Go away. It says that the measure of angle 3 is 60. Okay, so I'm going to put that in here. This is 60 degrees.
So they're all gonna be the
Angle
same
four
because those
is
are two
120.
parallel lines, right?
Let's make sure that we know why they're all the same.
Right
Alright, if this is 60, find something else. Eric,
1 is 60.
okay, why?
Vertical angle theorem.
Perfect.
Say that again.
That.
Vertical angle theorem, these are vertical angles,
now.
right?
Yes.
So perfect. Alright, give me something else.
Angle 4 is 120 because 1 and 4 is lunar pair.
Because 1 and 4, angle 1 and angle 4 are a linear pair. Okay, so 120.
So you could conclude that 8 is 120.
You include that all of them are
That's
120.
that's
That,
quick.
like
Let's
angle
slowly get
4
there.
Okay.
Angle 4 congruent angle 2 because because
120.
vertical.
Vertical angle theorem.
Okay.
With that.
Okay, so 120. Okay, what else? Why is the measure of angle 8 also 120?
Because same
SSIAP.
yeah,
Yeah.
Oh.
Same side,
angle theorem.
Interior angle postulate.
Mhm.
Okay, so this is also 120. Forgot to put 60 here. Okay, what is, give me
So
something
you
else.
Conclude that 1 and 5.
6 because vertical.
So 6 is 120,
Yeah.
vertical angle theorem.
And then 1 and 5 are the same because of the SSIAP.
I mean, I guess technically we found them all, didn't we? It said 2, 4, 6, and 8.
Oh well.
But let's just keep going excessively. So 5 would be 60 because
This is
Because
the
linear
SSIAP.
this would be linear pair actually.
Oh.
Because remember they're not,
Yeah.
well, okay, so you could either do linear pair or same side interior angle postulate.
Oh, I got it.
2 different ways.
Yeah, I did the same thing.
Alright, good. So basically a bunch of vertical angle and a bunch of linear pair.
Wait, I have a question. When
Yeah.
do you write the vertical angle theorem, like DATs?
So these two are congruent because of the vertical angle theorem. These two will be congruent by the vertical angle theorem. These two will be congruent by the vertical angle theorem, and these two will be congruent by the vertical angle theorem.
Alright, now what does the vertical angle theorem say?
It says that vertical angles are congruent.
Okay.
And
Alright.
vertical angles are angles that share a vertex and their sides, okay, hold on. Their sides are opposite rays, which means okay, so look at angle 1.
Mm-hmm.
This side is an opposite ray of the side of angle 3. And
Okay.
then angle 1's this side is opposite rays with angle 3's this side. That's what a vertical angle is.
Yeah.
Is that the sides are of each,
So basically we just
Are
flip
opposite
over
ways.
onto it. Like
yeah, exactly. Like if you could like,
mm-hmm.
yeah. Okay. What's the difference between a theorem and a postulate?
Theorem can be
Can be proven wrong.
Or right.
Or right, yeah.
And postulates,
Are like facts.
facts.
Fact.
They're
Can
true.
change them.
So the last one, the same side interior angle postulate, that was a postulate.
Fact.
It's a fact. This is a theorem, which means we could prove it. Okay, and we probably will. Not right this second. The alternate interior angle theorem. Okay, so you can abbreviate this alternate interior angle theorem says that alternate interior angles are congruent, which we just observed, right, in those last two questions, that these two are congruent. When we did all the math, we saw that they were the same. Okay, and again, this only works if a transversal intersects two parallel lines. If they're not parallel, it doesn't work. Okay, so if you have a transversal going through two parallel lines, then the alternate interior angles 4 and 6 and 5 and 3 will be congruent. Put this in a special place. Right now. So let's say you have like angle 3 is, well, yeah, we'll do like the 100 example, right? If angle 3 is 100, then that means this is 80, because they're a linear pair. We now know that 4 and this guy are congruent, right? And then this guy's going to be 100 too. Oh look, vertical angle theorem, vertical angle theorem, vertical angle theorem, vertical angle theorem. So you can see green and green are congruent. You see that? So it all builds, and it can build from vertical angle theorem, alternate interior angle theorem. They all have something to do with each other. Okay, so in short, make sure you add this to your list of theorems, the corresponding angle theorem. It's important that you know what a corresponding angle is. Okay, that one's like the harder one. Alternate interior is usually easy for people. Same side interior, usually pretty easy.
Oh, I've got it corresponding now pretty well.
Okay, so remember, corresponding means they're on the same side of the transversal, but one is interior and one is exterior. Okay, so like they're in the same apartment building, one lives on the second floor, one lives on the first floor. Okay.
Yep.
Cool. I'll give you a sec to like write that down with the little example. Okay, I think this is like the last theorem for a little while. Alternate exterior angle theorem. We're gonna abbreviate. Yeah. Alternate exterior angle theorem. So AET. Okay. Just says alternate exterior angles will also be congruent if you have a transversal going through two parallel lines. So lots of stuff's congruent. Make sure you're not confusing the things that are congruent and the things that are supplementary. Okay. Alternate interior angles, alternate exterior angles, corresponding angles are all congruent. Same side interior and linear pair stuff, those are supplementary.
So one more time.
Okay. Alternate interior, alternate exterior, and corresponding angles are going to be congruent. Same side interior and linear pair things will be supplementary. Okay, so the theme of the day is stuff's equal or stuff's supplementary in the broad picture.
So like interior and corresponding are supplementary.
All the alternate things and corresponding are equal. The alternate ones and the corresponding ones are going to be equal. The same side interior angles will be supplementary. And then you should know that linear pair stuff also supplementary. All right. Here we have a proof.
I forgot about proof.
They're not going away.
Are we gonna have to do them in the second semester?
They kind of go away in the second semester. All right, so
Or for now?
this is the proof of the alternate interior angle theorem, which means, you know how in English, if they're like, hey, what's the definition of belligerent? You're like, oh, it means to be belligerent. It's not a definition. You can't define a word with a word. In math, you can't prove a theorem with a theorem. That makes sense. Okay, so we have to prove this using everything except the alternate interior angle theorem. And we can do it. So it's the proof of, that means you can't use the theorem. So if I give you this on a quiz, don't use alternate interior angle theorem when you're proving the alternate interior angle theorem. The first thing we're going to say is just the given. L is parallel to N, and this is given. Okay, and it gives you some angles. We have to start talking about them. Okay, eventually we want to get that these two are congruent. That's our goal, the end goal. Before we start talking about that, we are gonna talk about other things.
Uh,
What other angle do they give us?
Angle 4 and angle 3 are supplementary because linear pair.
So let's use that. The measure of angle 4 and the measure of angle 3 equal 180 degrees because they're a linear pair. For this you can put linear pair postulate. This is where, when I told you to put all those, those postulates and theorems in the back of the book, this is where it comes in handy because you have things to work with. Okay, so these two make 180 degrees. We can also say something else.
Angle 3 plus angle 6 is 180 degrees because SSIA post.
So 6 and 3, which are these two, add up to 180 by the same side interior angle postulate. That was the first one we did. We were using that one because it says postulate. Alright. Okay. Alright. Now, if 4 and 3 are 180 and 6 and 3 are 180, then we know that the measure of angle 4 plus the measure of angle 3 has to be equal to the measure of angle 6 plus the measure of angle 3. Right?
Is there m between 4 and 6? The proof part. Proof.
One more time?
Is that m between 4 and 6? Like in proof? No, part with the one
Let's
higher.
say congruent sign.
The no, higher. Proof. In proof.
Where it says prove.
Oh, yeah, it says
Congruent.
congruent. It's this. Sorry, I was like, what are you talking about? Congruent.
Oh.
Yeah, yeah. Alright,
Yes,
so look. If A equals B and B equals C, then A equals C.
Transit.
Transitive property.
Ah, I remember that one.
I only remember that one.
It's a little
What
tricky.
else?
It's hard to see sometimes.
It's not as uptight.
Now, if you look at what we have now, do you see how the measure of angle 3 is on both sides? What if we just take these out? Can we do that?
Minus property of.
Yeah, exactly.
That's
Okay,
weird.
So we're gonna subtract the measure of angle 3 from both sides. That's the subtraction
Property of equality.
property of equality. Now we're here. What are we trying to get to? Congruent. So we're really close, right? Really close.
Yeah.
Why can we say that 4 and 6 are congruent?
Definition of the congruent.
Yes. Okay, so when we go from measure to congruence, that is the definition of congruence. You can also say, okay, angles with equal measure are congruent. That's the definition of congruence, is when stuff has equal measure, then they're congruent. That's what congruent means. When you're talking about what a word means, that's a definition. Okay, so you can just write definition of congruence there. Okay, and then that's it. We're done. Beautiful. Look how pretty it is.
It's just weird to subtract something that's not a number.